Analog multiplier. A basic multiplier schematic symbol is shown in figure. Here, two input signals Vx and Vy are provided. The output is the product of the two inputs divided by a reference voltage Vref. Thus, output voltage is a scaled version of X and Y inputs. The output voltage is given by V0 equal to Vx, Vy divided by Vreference. Normally, Vreference is internally set to 10 volts. So, V0 equal to Vx, Vx, Vy, actually it's Vy divided by reference voltage 10. As long as this condition is satisfied, as long as Vx is less than Vreference and Vy is also less than Vreference. If both inputs are positive, the IC is said to be a one-quadrant multiplier. A two-quadrant multiplier will function properly if one input is held positive and the other is allowed to swing both positive and negative. If both inputs may be either positive or negative, the IC is called a four-quadrant multiplier. So, the basic equation governing multiplier is ln Vx plus ln Vy equal to ln of Vx into Vy. The figure shows a block diagram of a log antilog multiplier IC. Log amps require the input and reference voltages to be of the same polarity. This restricts log antilog multipliers to one quadrant operation. Some of the multiplier IC chips available are AD533, AD534, AD633. Next we shall see briefly about analog divider. The voltage divider circuit can be constructed using a multiplier and an operational amplifier. This circuit produces the ratio of two input signals. The division is achieved by connecting the multiplier in the feedback loop of an operational amplifier. The voltage is Vden, that is denominator voltage, and Vnum, that is a numerator voltage, represent the two input voltages. Vden forms one input of the multiplier, and output VOA of op-amp forms the second input. The output VOM of the multiplier is connected back to the inverting input terminal of operational amplifier in the feedback loop. Then the characteristic operation of the multiplier gives VOM equal to KVOA Vden. No input signal current can flow into the inverting input terminal of the operational amplifier, which is at a virtual ground. Therefore, at the junction A, I1 plus I2 equal to 0. The current I1 equal to V numerator divided by R, where R is the input resistance, and the current I2 equal to VOM divided by R. With virtual ground existing at A, I1 plus I2 equal to Vnum by R plus VOM divided by R equal to 0. If you simplify this, you get VOM equal to minus Vnum. So this you can write KVOA into den equal to minus V num, or from this VOA output voltage is equal to minus V num divided by KV den, where as I already told, V num and V den are the numerator and denominator voltages respectively. Therefore, the voltage division operation is achieved.